Hello everyone, Mr. Cholman here. We're going to be talking about Unit 6, Lesson 16, Practice Problems. Okay, these are on page 143 of your textbook, or of your purple book. So it's the purple Unit 6, 7, Algebra 1 book. And over here on page 143, we're going to be doing number 1, number 2, number 3, number 4, and number 6. Okay, let's go ahead and get started on number 1. Okay, which equation can be represented by a graph with a vertex at 1, 3? Okay, so remember, a vertex is the turning point of any parabola, whether that's turning up or down, it doesn't really matter. It's just where it stops going up and starts going down, or where it stops going down and starts going up. Okay, so looking at each one of these equations, they're all in vertex forms, which means that this number right here is my h, and this number is my k. That's if the vertex were to be h, comma, k. Now remember, with the h, we have to switch the sign of whatever it is. Okay, so switch sign. The k stays exactly the same though. So whatever this number is, that will be this value in your vertex. Okay, so here's your k, here's your h. So looking at k, since it's 3, we know that these two are not going to work, right? Because their k value was 1. The h value over here, so it's either going to be -1 or +1. And since it's +1 here, that means we have to switch the sign from where it was in the equation. Okay, just like I said here. Okay, so in this case, the positive should be -1 in our equation, which is this one. So it should be A. That's the equation with the vertex of 1, 3. Okay, let's go and move on to number 2. All right. Where is the vertex of the graph that represents y equals x minus 2 squared minus 8? Okay, just like the problem up above, this is my h, this is my k, and we have to switch this sign right here, and this one stays the same. So the vertex for this one would be at the point +2, because we switch the sign, and then we keep the sign of this second one, -8. All right, there we go. Okay, where is the y-intercept? And explain how you know. Well, the y-intercept is always going to be the constant term. Now, in order to find the constant term, we have to actually expand this and then combine this -8 with the expanded version. By expanding, I mean like do that box method or the distributive property to go ahead and write this out all the way. Okay, so if I use the box method, right, I would go x minus 2, x minus 2, and then over here, don't forget the -8. And that's like, we're going to do that after we do our box method. Okay, so let's go ahead and make our terms. X times x is x squared. X times -2 is -2x. -2 times x is -2x. And -2 times -2 is +4. Okay, so if I write all this out in one equation, that turns into x squared minus 4x, because I combine these two, right, -2x and -2x, plus 4 minus 8. Okay, so I can combine these two, right, and that gives me x squared minus 4x minus 4, and this is your y-intercept, okay, right here. All right, so the y-intercept will be at the point 0, -4. And remember, your y-intercept is the constant term, okay? The constant term. That's the one without the x variable on it, okay? So we actually had to expand this. Remember, x minus 2 to the second power, like all that quantity to the second power, we have to write this out twice, okay? Another way to do it would be to say x minus 2 times x minus 2 minus 8, and then we would just use the distributive property aka the rainbow method, where you draw the rainbows. And you get x times x is x squared, which is right there. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 3 times negative 2 is positive 4. And all that turns into all this. Okay, so in order to identify, so anyways, that's the answer to B. So if we're doing C, in order to identify another point on the graph, all we have to do is take our original equation up here, and we're just going to plug in a random number for x. And let's do something easy, like let's do 1, because we've already had a 0 and a 2. Let's plug in the point 1. So when x equals 1, let's go ahead and plug it in and see what y equals. Okay, so 1 minus 2 squared minus 8, right? And that's the 1. And we want to know what this equals, right? Because that's going to be my y point for this, okay? So if I move over here to 1 on the graph, I want to know what the y is going to be, okay? So 1 minus 2, that's just negative 1 squared. Negative 1 squared is positive 1. So this equals positive 1 minus 8, which equals negative 7. So another point is going to be 1 comma negative 7. Remember, this was my x, and this was my y. Right? It says y equals this whole thing. All right, so let's go ahead and sketch the graph that represents this equation. And all we have to do is just plug in all these points. So we're going to plug in, this point, or graph this point. We're going to graph this point, and we're going to graph this point, and hopefully we'll be able to draw a nice little parabola. Okay, so 1, negative 7, right here. Point 1 comma negative 7. 0, negative 4, that's right here. 0 comma negative 4. 2 comma negative 8, that's right here. 2 comma negative 8. And since this is the vertex, I can mirror this with these other points over here, like this. Okay, so all we have to do is connect these dots, and you got yourself a nice little parabola. Just like that. Okay, so that's number 2. Let's go ahead and move on to number 3. The function v is defined by v of x equals 1/2 times x plus 5, all that quantity squared, minus 7. So graphing to determine if the vertex of the graph representing v shows the minimum or maximum value of the function. Okay, so remember, a minimum value would be if the parabola looked like this and it was opening upwards, right? That would be like the minimum value would be the vertex. A maximum would be like going the other way, where the parabola would be opening downwards, right? And the vertex would be the maximum. Okay, so what we want to figure out is, does this show a vertex going up or a vertex going down, right? And this number right here tells us. If this number is positive, which it is, then it's going up or opening up. If it's negative, then it's going down. And if it's going down, then this would be the maximum. If it's going up, then this would be the minimum. So this shows us a minimum. A vertex is minimum. Okay, so there's number 3. Let's go ahead and move on to number 4. Okay, since we know all this stuff about minimums and maximums and where the vertexes are, it's going to be easy for us to see which one of these graphs goes to which function. Okay, so again, this is going down because it's negative. This one is positive, so it's going up. This one's going up. This one's going down. Notice negative, positive, positive, negative. So these two are either A or C, and the difference between the two is one has a 6 in front of it, the other one has just nothing, or a 1 in front of it. Now, if you have a 6 versus a 1, this one is going to be going up a lot faster. It's going to be like a lot skinnier, right? If it's a 1, it's going to be a little wider. Okay, so the skinnier one is C, and the one that's not as skinny is A. So, okay, now these two are going down, and this one is times 2, so it's going to be skinnier. This times 1 is times 1, negative 1/3, so it's going to be going down, and it's going to be wider than that regular one with a 1 on it. So the widest one is D, going down, and the skinnier one going down is B. There you have it. There's number 4. Pretty straightforward. We're just looking at the A values. Okay, that's this number in front of the parentheses. Okay, last one, number 6. Kind of review, we're just analyzing what's happening here. Claire throws a rock into the lake. The graph shows the rock's height above the water in feet as a function of time in seconds. Select all the statements that describe this situation. If we look at this, what can we tell? We can tell that she throws the rock up here, it goes up in the air, and then it comes back down and lands in the lake right here. Okay, the vertex of the graph is 0.75, 29. Yes, that's true. There's the vertex. So this one's true. The y-intercept of the graph is 2.10. That would be like right here, and that's not true. Claire just dropped the rock in the lake, which means if she's right here, she dropped it, it'd be like, bloop, right? So we know that's not true, because the rock went up. The maximum height of the rock is about 20 feet. Well, that's right here. That's not the maximum. The maximum is way up here, so that's not true either. The rock hits the surface of the water after about 2.1 seconds. Well, here's 2.1 seconds, and yeah, that looks like the surface right there, so I'm going to say yes. Claire tossed the rock up into the air from a point 20 feet above the water. Yeah, so she was here, and she threw it up, and then it came down. So, easy peasy, lemon squeezy. Okay, if you guys have any more questions, please email me or your teacher, and we will input it for you. All right? Keep up the great work, guys. Only got a couple days left.